All right, so a big focus of ours in this unit is going to be simplifying radical expressions. I'm going to show you two separate methods in this video. Both methods I'll do the same example with, so you can then choose which method you prefer, because then I have two videos that are strictly examples, multiple examples with the method you choose. And in that other video that you watch, you can watch all of it, or you can just watch as many examples as you need to completely understand it. So the first method is going to be rewriting radicals as rational exponents. These are going to be my steps. So I'm going to go ahead and walk through those steps on this example. So the first thing I'm going to do is put numbers under their own radical and simplify. So square root 32 will go under its own radical. And I'm just going to leave these as is. I know the square root of 32. I'm going to do a little side work because I want to make sure I have all my room for this example. I know that the square root of 32 is the same thing as the square root of 16 times the square root of 2, which is 4 square root of 2. That is step 1. Now I'm supposed to change all my variables to exponential form. Well, I see this as a square root, which means index of 2, so I'm going to change this to be x to the 5 over 2, y to the 4 over 2, z to the 3 over 2. Okay, step 2 is done. Now I'm going to change my exponents to mixed numbers. Okay, so this 4 square root of 2 is going to stay in front. This is going to say 2 goes into 5 twice with 1/2 remaining, and that's just me doing some long division. If you are unsure of how to do this, please talk to me. I will not go through it in this video. 4 over 2 reduces to just 2, so the mixed number essentially would be 2 and 0 halves. And 3 over 2, it becomes z to the 1 times z to the 1/2. Okay, and now the final step. My whole number part comes out of the radical, so it's going to stay. So this x squared is going to remain an x squared. This y squared is going to remain a y squared. This z1 is going to remain a z1. But any of my fraction parts, I'm going to change back to radical form. So 1/2 will become the square root of x. 1/2 will become the square root of z. So finally I'll have 4 square root of 2, x squared, square root of x, y squared, z to the 1, which is the same thing as just z, square root of z. And in both of these methods, I'm always going to regroup. So I'm going to group for my best final answer all of my things that are out of radicals. 4x squared, y squared, z. And everything that is in a radical, I'm going to put under the same radical. 2x, z. There will be my final answer. Okay. If this method makes sense to you, you are going to watch the next video, which is going to be labeled examples simplifying radical expressions with rational exponents. If you would like to hang around and see the second method before you make your decision, I'm going to go over that next. The second method is taking out groups. So again, I have my steps here. Notice step 1 is the same. And again, I'm going to go through these steps via example. So I've already looked at how I'm going to first, well, I guess I'll just go through it. Square root of 32, square root of x to the 5th, y to the 4th, z cubed. And I already looked at how the square root of 32 is the square root of 16 times 2, which breaks down to be 4 square root of 2. So I looked at that just momentarily ago in the previous example. X to the 5th, so now I'm going to give each radical its own variable its own radical. So I'm going to say square root of x to the 5th, square root of y to the 4th, square root of z cubed. Okay, there was step 1 and step 2. Step 3, I'm going to take out groups of variables as indicated by the index. So I don't have an index written, but remember that with square roots, it's like there's an index of 2. So I'm going to go ahead and leave 4 square root of 2. I'm done with that. And I'm going to ask myself, if I have 5 x's, how many groups of 2 can I make? Well, I can make 2 groups of 2, so I'm going to say x squared, and I'm going to have 1 left over. Okay, so the 1 left over I'm going to leave under the radical. So steps 3 and 4 I'm essentially combining here. And then I go to y to the 4th. All right, if I have 4 y's, my index that's not written is 2. How many groups of 2 can I make? I can make 2 groups of 2. I don't have anything left over to put under a radical. And finally, if I have z to the third, if I have 3 z's, how many groups of 2 can I make? I can make 1 group of 2, and I have 1 left over that goes back under the radical. Now, just like in the previous example, the last thing I'll always do is group everything in terms of things that are not under a radical along with things that are under the radical. So notice that I get the same answer either method. If you think this method makes more sense to you and you would like to see some more examples of this, you are going to watch the video that says examples simplifying radical expressions by taking out groups. As I said in the beginning of this, I do not care which method you choose to use. Pick which one works for you. Pick which one makes the most sense for you. Watch some more examples of it. Pick the video based on the method you choose.